Very good, Rich.
Yeah.
We've been having an issue with permissions, and I think it might be a thing with Unity 5.
Okay.
I couldn't zip it up, and when I just straight uploaded the files on like Google Drive or something, he couldn't open it.
I can't pull them down
or modify them. And so I tried changing the permissions naturally, and apparently it didn't stick because I did that before I uploaded it, and he still couldn't mess with it. So
Okay.
I don't know what was going on there.
That's weird. I will try to zip this game that I made up and put it out there and see if people can download it.
And I haven't had to do that with like Unity 4 or anything. So
Okay.
I just an issue.
I will try to test that out too. Nobody's turned in their stuff yet because it's not due till tomorrow. So I haven't seen anybody say that problem. I will see what I can do. Okay. So last time we talked about state machines. State machines. Just to remind everybody where we were. State machines. States, transitions. There's this one. It says, what should I do about coffee? How does the espresso maker work? You can program those little things. State machines are everywhere in our lives. We can program them into our games. Any questions about how to do that with our simple if statements and a bunch of if statements? It gets tedious. It gets annoying to try to continually code and change our state machine back and forth. So we want to add a new state. We have to add a new outer loop. And we have to figure out some new transition condition. All these different transitions. You could have multiple transitions. Now you've got to reconfigure it with your code. People have taken this and made tools that you can use in Unity. Let's go see one of those quickly. We can go to, in Unity, the asset store. I've not seen that before in class, but it's another box. Opens up. There are things that people have made and said someone else might want to use this in Unity. They either give it away for free or they charge you money to download their code and their tools. Because you notice whenever we make a script over here in Unity, whenever we make a script and we drop it onto an object, it shows up on the right-hand side inside this box. And all the things we said are public show up as draggable, put things together. You can make this box as complicated as you want. You can make that box do all the things that these other standard boxes come with Unity can do. It's very extensible. And you could say, I want to put in an image box here. I want to put in all these other tools and dragging things back and forth. Notice that when I clicked on height, my cursor shows up with these extra arrows, which means I can drag it back and forth without typing in numbers. You can do all that stuff within your Unity code in the C# part to make your box look as good as possible. So you can make a really cool tool for somebody in Unity, and other people can download it and start to use it. So people have done that as they said, hey, we need finite state machines. So in the asset store, people have created tools about finite state machines. Let's go look at Playmaker. Playmaker helps you put AI into your programs, and it helps you just graphically get a screen that shows up, and you can create a state machine. Move to the target. When you're finished with that, inflict damage, finished, check for death, target death, etc. Navigate around there, and you put it together graphically, and all the code is created for you underneath it, and then you can just pop that into your game. So there's lots of places out there that let you just incorporate their tool into your game and draw your state machine. But there's still sort of a fragile thing. You have to think of all the transitions. You have to think of all the different states. And in some ways, people have been moving toward thinking about the behaviors and separating them out from the structure of where they happen. A state machine puts those together. It says, when you're in this state, you do this behavior. And if you want to change your behavior, you have to figure out how to leave this state. But the separation is going about to say falling over is some kind of action that happens. You might want to do it in 3 or 4 or 5 different scenarios, and you don't want to be able to, you don't want to make sure, you don't want someone to have to think of all the possible scenarios beforehand. They might think of all the actions and when they're happening, but there's different ways to put that together. So then people started to think about, how do I put this together in trees instead of a graph? And the tree is the behavior tree that people have come up with. You might be familiar with decision trees. Has anybody heard of a decision tree? Decision trees are a branching system. They're just a bunch of if statements, and it lets you say, ask a question, follow down within my tree, where do I get to an end node that gives me an answer? There's going to be one answer that comes back from a decision tree. Many times they're used in classification purposes to say, should I do this or not? Let's look through my decision tree, let's look at this decision, and I ended up down here in this leaf. That's what I should be doing. This is something you would have to run every single update. You'd have to wander through your decision tree every single update and figure out, what is my particular action based on all these different possible combinations of what's going on. So they took this idea and sort of turned it into a behavior tree. Let's talk about a behavior tree. Here's one possible example. These are different types of behaviors of what you could do as a bot inside a game. And they have slightly different relationships than we might have expected before. There is this particular path which is being followed right now, but you can specify how the behaviors fit together in a loose sense of a state machine, but not completely put together. So let's walk through a little bit of that. This is the best tutorial I had found on behavior trees. There's like 6 or 7 that I tried to read, and 6 of them did not make sense. So the 7th one did make the most sense, and it should help the other ones make sense when you go to read them. So a behavior is trying to talk about, where is it? This part. That chunk of code that's inside the state that we were doing before. Once you get into a state, what are you supposed to do in that state? That's what we're going to call behaviors, or in this tutorial, routines. What is the stuff you do? And it takes that and extracts it and says there's a general sort of thing that a routine is. A routine is a state itself that could either be currently running, currently happening, or in 2 states, success or failure. This is a behavior that tries to happen, some action that the program tries to do, and it either works, or it doesn't, or it's trying to work. 3 different things that a behavior can be doing. And if there's these 3 states, success, failure, and running, then the routine has to be able to say, somehow I have succeeded, I have failed, or I'm currently acting and I'm running, I'm trying to do stuff. So this is the general abstract way to talk about a behavior, an individual behavior. Behaviors are either trying to do stuff, or they worked, or they didn't. Does that make sense? So an individual portion of that code. We could talk about that here. Somebody's trying to fetch the destination. Is it at the destination yet? Is it there yet? Is it there yet? This kind of question is within the fetch state. This is how it starts to fetch. This is how it knows when to finish. And if it gets there, then it succeeds. If it doesn't get there, it fails while it is going and still trying to fetch. And getting closer and closer, then it's currently running. So we take those pieces of our code here and put them inside this other framework. And that, in essence, lets us put those routines, those behaviors together in a different structure. We don't need to think about the transitions between them so much as the ways that they might be logically connected. So, for example, this tutorial says, here's how I would extend routine to be a move to. Very similar to what we were talking about to go fetch. It said, here's my destination X, destination Y. Somebody says, go move here. I start it, and I see if I'm running, and if I'm still alive, then I'm still going. I try to move. But there's ways for me to say, if I got to the destination, I succeed, change my state to success. If I die somehow, change my state to failure. Otherwise, I am currently running. So this behavior is taking those abstract ways of success, failure, and running and saying, these are the implementation details of what that means. Does that make sense? It does what our state machine did in a different way. It takes this part, and it takes this if statement up here, and puts them into other types of methods that then set off these flags, success, failure, or running. And so if an individual behavior can try to be doing stuff, its update happens every time step around the loop, and it lets us have routines with a single responsibility, and it lets us start to put them together in interesting ways. Once we have enough of them, we can start to make other types of routines that let us make a tree. So here was that move to, and it's a leaf in this tree. It's something that actually tries to do something. And all of these sort of make sense based on their names. Is there a droid in the range? It's a behavior that you try to answer yes or no. Did I succeed or fail in answering this question? I'm trying to attack the droid. There's probably a lot of code in there about moving, attacking, hitting things. All of that's part of a routine, a behavior that's happening. Move to is showing up in two different places. Attack droid is showing up in two different places. This question about is the droid weaker? This question about finding a safe tile. All of those are going to be defined as a routine. And then you compose them together with a couple interesting types of internal leaf nodes. You could have a leaf node that is just a repeat node. It's a routine itself, and it tries to succeed by running all the ones underneath it. It fails when everything fails, but then it repeats and tries to do it again. So this is how we set up our eternal tree to go try to do stuff all the time. We're always trying something. The next type of thing you'll see is a selector, which acts like an OR statement. Try the one on the left. If you can get anything in there to succeed, then good, you're done. Go back up to the root and repeat and do whatever you want. If the one on the left doesn't work, then try the one on the right. If the one on the right doesn't work, try the one on the right of that. You could have 3 or 4 or 5 children of this, but a selector node lets you put things together in a logical order. Try these 5 things. This is the priority and precedence. So here it says the first thing you should do is try to go find a droid and attack it. If you can't find one, or if you failed at moving around, then just go wander randomly. It sets up that if-then precedence by putting them in the tree in a certain order from the left to the right. Okay, this one here is a sequence internal node, which says if you want to succeed, it's an and both of the things underneath you have to succeed. The selectors are ORs, the sequences are ANDs. So over here, if you're going to succeed, you need to find a droid in range, and you either attack the droid or run away from it. That's the kind of logic that's being specified here. If there's a droid in the range, well, then you try to go attack it. If the droid's weaker, you actually do attack it. Oh, well, if the droid is not weaker, this part fails, but it's a selector, so it's an OR. I can go over to the right